Today's project is something I've been really excited about. In my previous video, I salvaged a set of 18650 lithium cells from a faulty Stihl battery pack that had a BMS issue. The cells were still healthy, so instead of letting them go to waste, we are giving them a second life. In this video, I'm building a 12V lithium battery pack using those reclaimed 18650 cells, paired with a 40A BMS. I'm planning to make several more 12V battery pack because 12V systems are extremely popular. They are used in solar setups, camping systems, backup power, automotive application, you name it. I'm also preparing these packs for an upcoming solar project, so this is just the beginning. Then here's the 12V battery casing I'll be using. This particular case holds 21 cells, which is perfect for building a solid 3 series configuration with enough capacity for good runtime. Before I even begin this build, I want to show you something very important. My fully charged fire extinguisher. Whenever I work with lithium cells, I always keep this right beside me. Safety is not optional with lithium batteries. One short circuit or mistake can cause serious damage, so always be prepared. Now that we are set up safely, let's go into the build. I start by arranging the 18650 cells carefully into the battery holder, making sure polarity is correct and the series groups are properly aligned. Once everything is positioned, I place nickel strips across the terminals. For welding, I am using my DIY spot welder, the same one I built in a previous video. It's perfect for this kind of job because spot welding avoids overheating the cells unlike direct soldering. I carefully begin spot welding each nickel strip, making sure every connection is solid but controlled. Once the cell connections are complete, it's time to install the 40 amps BMS. This is what protects the battery from overcharging, over-discharging, and short circuits. I solder the balance leads and main power leads into the PCB, double checking each connection before moving forward. I insulate the entire battery pack using Kapton tape to prevent any accidental shots to keep everything secure inside the casing. The next step is testing. I grab my multimeter and check each series group voltage to make sure everything looks correct. No surprises, no imbalances. So the total pack voltage reads about 11.2 volts, which makes sense because the cells needs charging. Now it's time to bring this pack to life. I set my charger to 12.4 volts at 1000 milliamps to start slow and safe. While charging, I keep monitoring the temperature of the cells. Once I confirm there is no overheating, I increase the charging current to 2000 milliamps. I also connect my multimeter directly to the battery terminals to monitor the live charging voltage. Everything looks stable, exactly what we want to see. After the pack reaches around 12 volts, I disconnect the charger and it's time for a quick load test. I hook up a 12-volt light and there it is. Bright and stable, the pack is working perfectly. Finally, I close the plastic battery housing and seal it using a 2-compound JB Weld adhesive to ensure a strong, durable bond. And that's it. A fully functional 12-volt lithium battery pack built from salvaged 18650 cells. This is the first of several 12-volt packs I'll be building for my solar setup. So stay tuned for future builds and system integration.